students, today we can see some problems based on the relation between orth moment about origin and moment generating function. First problem, if the orth moment of a continuous random variable capital X about the origin is or factorial. Find the MGF of capital X. Simple question. Actually, what is given? Given is orth moment of a continuous random variable about origin. So mu or dash is given, which is nothing but or factorial. What actually we need to find? M x of t, a moment generating function about origin. But what we know, mx of t is summation over r equal to 0 to infinity mu r dash into t power r by r factorial. So here mu r dash, which is nothing but r factorial, when you substitute in the summation r factorial into t power r by r factorial, these two things are cancelled. When you expand the summation, it comes as t power 0, which is 1 plus t squared plus etc. This is nothing but the binomial expansion. When mod t less than 1, we can write it as 1 minus t to the power minus 1, or simply we can write it as 1 by 1 minus t. Therefore, we found mx of t equal to 1 by 1 minus t. Now we can solve one another problem. Second question, if the MGF of a random variable capital X is 2 by 2 minus t, find 2 minus t here, find the standard deviation of X. What is given? Moment generating function about origin, that is 2 by 2 minus t. This can be written 2 by, when you take 2 outside, it comes as 1 minus t by 2. 2 and 2 are cancelled. We can bring this up. 1 minus t by 2 to the power minus 1. We can expand it like this: 1 plus t by 2 plus t by 2 the whole square plus etc. It goes like this. Now, what actually we get? Mx of t is the infinite series of the terms. 1 plus t by 2 plus t by 2 the whole square plus etc. Now we can write its mean value E of x. In terms of moments, we can say this is mu1 dash. Actually, what the relation between mu1 dash and mx of t we studied already. The coefficient of t by 1 factorial in mx of t. So we can get the mean as t by 1 factorial. Here we can multiply and divide 1 factorial. Why? Because there is no change will come. Simply we can say this is t by 1 factorial means 1 by 2 comes. So here the mean is 1 by 2. And the variance of x mu 2 dash minus mu 1 dash the whole squared, where mu 2 dash equal to the coefficient of t squared by 2 factorial in mx of t. T squared is here. 2 factorial we need. So here we can multiply and divide 2 factorial. When you left t squared by 2 factorial, the remaining it comes as 2 by 4. So again it comes as 1 by 2. So the variance is also comes as 1 by 2. Now the standard deviation we have to find, Therefore, variance of x equal to E of x squared. E of x squared is 1 by 2 minus E of x the whole squared, it is 1 by 4. So 1 by 2 minus 1 by 4, it comes as 1 by 4 variance. Standard deviation of x equal to square root of variance of x, that is equal to 1 by 2. One more question we can do now. Find the MGF of a random variable capital X whose moments are given by mu r dash equal to r plus 1 factorial. Here MGF we have to find its rth moment about origin is given. We can start with the given term mu r dash equal to r plus 1 factorial. We have to find m x of t. Now the relation between these two things we know that as mx of t equal to summation r equal to 0 to infinity mu r dash into t power r by r factorial, isn't it? That is equal to summation r equal to 0 to infinity r plus 1 factorial, which is given in the problem, t power r by r factorial. When we split the r plus 1 factorial into summation r equal to 0 to infinity r plus 1 into r factorial into t power r by r factorial, we can cancel these two things. It comes as summation r equal to 0 to infinity r plus 1 t power r. Now we can expand this, that is equal to 1 plus r equal to 0 means 1 into t power 0, 1, simply 1 comes, plus when r equal to 1, 2t, plus when r equal to 2, 3t squared plus 4t cube plus up to etc. That is equal to 1 minus t to the power minus 2. This is again the expansion like this. So we can get mx of t equal to 1 minus t to the power minus 2. Thank you.